Thank you, John. Yeah, as mentioned, my name is Kyle Broderick. I am the coordinator of the Plant and Pest Diagnostic Clinic at the University of Nebraska-Lincoln. So really, we deal with all things that involve adverse plant health. I primarily do the diagnostics for pathogens, so the rots and the spots, the fungi, viruses, bacteria, those fun things. But we also do work with entomology. So I have some great entomologists that I work with, some great people at Plant ID as well. If you have some pesky weed that keeps popping up and you don't exactly know what it is, we are available to answer all of those questions and try to figure out what best management practice we can institute in our landscape or our garden. And so as today we are talking about the good, the bad, and the ugly of pest control. And really, I wish that I owned the rights to some Ennio Morricone music, just to have some nice spaghetti western diddling in the background, but not quite sure how that would handle going up on YouTube and copyright laws and all that jazz. So, all right. And as John had mentioned, this is only our kind of part one of a two-part series. In a couple of weeks, I'll be back on August 24th to discuss the good, the bad, and the ugly of organic pest control. So today we are going to be focused more on chemical control, some of these non-organic options that we have, just because that's where I tend to get most of my questions and see most of the problems as well. So first, just want to bring your attention to the IPM toolbox, or integrated pest management. Very, very important whenever we are thinking about managing any pests in our garden. Does not matter if it is a disease, doesn't matter if it's an insect, doesn't matter if it's weeds, or if it's birds, or maybe you have rabbits, raccoons, squirrels, some of these larger pests. We have a variety of tools that we can use in order to manage any of these guys. But it's critical to remember, or it's critical to make sure that we are picking the right tool for our right pest. And so chemical control is really only one of those tools that we have. We also have resistant varieties. Very, very effective. Generally, resistant varieties will be your cheapest and most effective means of managing almost any disease issue in the garden, but also a lot of insect problems as well. Or if it's an environmental stressor that you consistently deal with, maybe you have some very alkaline soils, making sure that we're looking for a variety that can handle those specific environmental conditions is great. So whenever we are thinking about integrated pest management, resistant varieties are always one of the first things that you want to think about. We also have some of these other cultural controls, such as crop rotation when possible, trying not to plant things in the same area time after time, and if able, to really be rotating those things throughout the garden or throughout the landscape. This is especially important for our pathogens, especially the soil-borne pathogens, because if we would continue to grow the same plant in the same area after year, eventually we will get a buildup of given pathogens in that area. Crop rotation sometimes kind of works for insects. Unfortunately, though, a lot of insects can move, and one of the beneficial things about a lot of our fungi and bacteria is they can't really scurry or kind of walk over to that tomato plant. They have to make sure that they have to be in the area where that plant is actively growing. But so we've talked about the IPM toolbox. We have all of these different tools we can use. One of the most common tends to be, though, chemical control. And so when we are going to use those chemistries, a few things that we want to think about. We really want to be applying mixes of different pesticides, of different pesticide groups, and try to rotate these pesticide groups if we're doing multiple applications in a given season. It's very important in terms of just pesticide stewardship. We also really need to make sure that we are following our label recommendations. So any pesticide that you purchase will have a label written on it. And that label is a legal document. And on that label, we'll have the instructions on how to properly apply it, the product, also what plants it can be applied on, and what pests, so which insects, which weeds it controls, which diseases it controls. But one of the main things I wanted to draw your attention to is only applying pesticides when warranted. We don't want to be applying some of these chemical pesticides just because we see our neighbor applying them, or because the calendar switched to, what is today, July 26th. We don't want to be applying things very often purely based on the calendar date. Really want to make sure that we are out in the landscape or in the garden scouting, trying to get an idea about what the disease, what the pest pressure is, before we start to implement any of these controls. Or additionally, maybe you have an issue, a certain disease or a certain insect that you deal with every year. And so it's just, that it's always going to come back. One of the great examples that we have for this would be some of our rust, such as cedar apple rust. If you've been looking along at pear tree, a lot of Bradford pears, apple trees, crab apples, just about now the leaves are starting to look like they've almost been spray painted orange. And so, what we always want, we want to be scouting, making sure that we do have the disease present. But some diseases, some pests, we want to be applying these pesticides based on disease risk or a forecasting model. And so with the rusts on ornamental pears, crab apples, and apples, right now, this is when we are starting to see a lot of the injury. Applying any pesticides right now is too late, and we're not going to get good control. And so this would be an example of knowing what the problems are, knowing that the problem will come back next year. And at least in the case of cedar apple rust, that's one that we want to apply a fungicide early in the spring, kind of right as the flowers are beginning to open on those ornamental pears, apples, or crab apples. But again, really scouting early and scouting often is critical to any sort of pest management program. And when we are out there scouting early and scouting often, then we can really get a better sense of how effective will this pesticide application be. And so we just have a little kind of a basic graph here that shows a few different things. And so one thing that we often talk about is the economic threshold. And so the economic threshold for pest control is beneath that threshold, treatment just will not be profitable. And so it does not matter how much you apply or anything. You're not going to see a great impact from your pesticide application. And that's kind of the lower line that we have here on this graph. But then the line that we have above that is our economic injury level. And that's one that, especially if it's a production garden where maybe you're wanting to be selling things at a local farmer's market, or you want to be producing a lot of material to can or do some other value added processes to. But that's the economic injury level. And that's the level that we tend to see our economic loss occurring. And so this is especially important with a commercial production, because if we have injury beneath that level, we won't see any injuries. So it really doesn't matter. But like I said, very important to be thinking about that economic threshold or that injury level before we are applying any of our pesticides. But really, to start with the good, the bad, and the ugly. So some of the good things about our chemical pest control, we often will see decreased pest pressure, which is what everybody wants. We're going to have decreased competition due to weeds in the garden. Every weed that is popping up, that's going to be stealing nutrients, it's going to be stealing water. Potentially, depending on the size of the weed, it may even be stealing sunlight from the plants that you are trying to grow. Also, with our chemical pest control, we will normally improve overall productivity of the garden. And isn't that the main thing that we all want in a garden, right? I mean, I enjoy watching plants grow. If I have tomatoes that never actually fruit, it's really not going to be a whole lot of benefit to me. So we really want those gardens and those landscapes to be productive. And also, we will normally see reduced labor costs. And so, as we think about, yes, there are a lot of mechanical options that we can do. We can be out hand weeding everything, but that takes a lot of time. And maybe you don't have the time available to do a lot of that. Or we'll often talk about mechanically removing some infected leaf tissue. Maybe it's towards the bottom of the plants, as we're trying to remove these leaves that are showing some of the leaf spots early, to try to decrease the amount of disease potential. Again, that does take time. Or with insects, you're out squishing those individual guys. One thing that I've dealt with for a few years now has been squash bugs, and boy, I hate those things. I try not to say I hate a whole lot of things, but man, I have lost way too many squash to those dang bugs. But one of the great ways to control those bugs is to be out scouting early and scouting often. And when you see some of those egg masses occur, just to remove those egg masses and kind of squish them, or when we have low populations of the insects, to just go out and kill them or drown them as best you can. But in general, I'm not going to spend a whole lot of time really talking about the good of pest control, because that's something that all of us have probably experienced, and we all know what a well-managed garden or well-managed landscape should look like. But now we also have the bad. And so some of the bad things that really can occur with chemical pest control. Well, we can have off-target effects. Really don't want those to be occurring. We're applying a product, hoping to control one thing, and maybe we end up controlling something completely different, maybe something beneficial. We also can have ineffective applications. And so maybe we've gone and we've applied this product, but it doesn't do anything. And so you've wasted your money on the product, you've wasted your time to make that chemical application, and it's just not doing what it should be. One of the other bad things that really can occur with chemical control can be adverse health effects. Now, one of the things I really want to stress is pretty much, well, at least every most non-organic chemical pesticides have gone through very rigorous testing, looking at their effects on both off-target populations, but also their health effects on people. And if any of these products were very toxic to people, there is very low likelihood that they would actually be released into the commercial market. And so again, I want to stress that all of these products that you can go and buy at your general garden store have been very heavily researched and for the most part are considered safe. Now, it can be difficult doing some of that testing, especially when we're looking at low-level chronic exposure of some of these pesticides. And so when we have a low exposure to these chemicals year after year after year, you know, sometimes maybe for 20, 30 plus years, it's almost impossible to accurately study those effects. So even while these products have been deemed safe by the USDA testing facilities, we don't always know what the long-term chronic exposure effects can be. So it is possible that we will see some adverse health effects. But starting off with just some of our off-target effects. And so one thing to remember, most of our pesticides are not selective. And even those pesticides that we apply that are selective, they are going to be semi-selective at best. So there are not any herbicides that will only control dandelions. They will control maybe there are some that will only control other plants within that same family as dandelions, but most of them will control pretty much any broadleaf weed. Same as with a lot of our insecticides. You know, we don't have an insecticide that only attacks Japanese beetles. We have some that are semi-selective for Japanese beetles, but they will often have some off-target effects. And you may not think that that's really that big of a deal, but there are a lot of beneficial things, other beneficial organisms in the landscape, in the garden. And so a lot of insects are very beneficial. We always think about our pollinators. We really want to we really want to protect our pollinators anytime we're doing some sort of insecticide application, making sure that we're applying those insecticides earlier in the morning or kind of late in the evening to avoid that time when the pollinators are going to be most active. But same as we have very beneficial fungi and bacteria and just some other kind of other organisms in the soil, such as nematodes, such as protozoa. But a lot of these microbes that are in the soil that we can't see with our naked eye, we really have no idea what they're doing, but they're very, very important for that nutrient cycling process to occur. And so as we have plants that are breaking down, they're going, you know, we hope that they are going to be releasing carbon and other nutrients back into the soil if we till them in. Fungi and bacteria are very critical for that nutrient cycling process to occur. Now we can also have ineffective applications. And one of the main things that I see with these, or one of the main reasons I see that we have these ineffective applications, there are a few things. One, we could just be at the wrong time. Maybe we're applying pesticide trying to control something that is not here yet, or based on the weather forecast will not be a problem. But the main thing that I tend to see with our ineffective pesticide applications is that we're targeting the wrong thing. And so these are some beans that had come in, or I'm sorry, peas that came into the clinic. Right here, this was a couple of years ago. This sample came in, and as we can see, a lot of injury. And this was a commercial garden pea producer, and so he was very concerned about this blighting that he was really starting to see take over most of his pea production area. where he had these dark lesions that were occurring on the stem, but also on the leaves. And he really wanted to make sure that he was taking care of those. So he sent the sample into me to figure out what was wrong. Unfortunately, after he sent the sample to me, but before it got to me, typically there's a 2 to 3 day lag time, just based on how long it takes the mail to come in. He had applied a fungicide. Well, I had looked at this sample and there was nothing fungal with it. Instead, it was a bacterial disease. And so the two images that we have here, on the left, we have just a lot of some general fungal spores. The broad spectrum fungicide that he applied would have taken care of pretty much all of these fungal spores that are shown here in the image. But fungicides do not affect bacteria. And so this was a bacterial disease. This was a bacterial blight of peas. And unfortunately, his fungicide application ended up being mostly worthless. He did not see the control that he was after, because again, the broad spectrum fungicides had no control over the bacterial pathogen that caused this disease. And the image that I have here on the right, where it's just kind of that cloud that's kind of going down the screen, I had taken part of these leaves and just cut a little section out where the lesion was. And what we see here are millions of bacterial cells literally gushing out of the infected plant material. Again, because it was a bacterial disease that he was trying to control, fungicides did nothing. Same, there may be just some random spots that you're seeing. Maybe they're caused by an insect, or you think they're caused by an insect when in fact it's a fungus. A lot of our foliar diseases, they make once we have those lesions mature, the center of those lesions may drop out, and so you have just kind of ragged holes in the leaves. They may look very similar to insect injury, but applying a broad spectrum insecticide will not control those fungicides. So really important to know what you're after. And at least on the disease side of things, so trying to figure out whether it is fungal or bacterial, I highly recommend people get comfortable making their own humidity chambers at home. And that's one of the main things that I do in the diagnostic clinic. When a sample comes in and I don't really know what's going on, I will put that sample into a clean, airtight container with a damp paper towel, and just let it sit for 24 to 48 hours. Sometimes it takes a little bit longer. Maybe it takes up to 72 hours. But after that time, we will start to see some evidence of, is this disease caused by a fungus? Is it caused by a bacteria? And if it's caused by a fungus, we may start to see some of that nice kind of cobwebby, cottony growth occurring out of the lesions. Where if it's a bacterial disease, we may see that growth. It normally won't be associated with lesions. It could just be another saprophytic secondary pathogen, or I'm sorry, secondary fungus that's living on the plant surface. With bacterial diseases, that's when we tend to see just some bacterial exudate that shows up on the leaves, and that's the image that I have here on the right, where we can just see some of those droplets that are full of bacterial cells arising from those lesions. And if you're ever uncertain about your diagnoses, there are lots of diagnostic labs around the country. There are plenty of commercial diagnostic labs out there, but I tend to advocate for the non-commercial labs that are often based at some of our land-grant universities. And so we are all a part of the National Plant Diagnostic Network. Every state in the country has at least one NPDN affiliated diagnostic lab. In Nebraska, it's my lab. And so you can always, but regardless of where you are in the country, there is a lab there to help you figure out what is wrong with your plant. Again, knowing what you're trying to combat is always the first step to any sort of management practice. And if you are located in Nebraska, or even not in Nebraska, we get samples from all over the country. But this is the contact information for my diagnostic lab. But again, these diagnostic labs are really throughout the country. And if you are going to submit a sample for proper disease ID, really want to make sure that it's a quality sample. The accuracy of any diagnoses is a direct result of how fresh the sample is, and also a lot of the background information that tends to be provided. Well, some of the other bad things about our chemical pest control are the adverse health effects. And again, I had mentioned that most of these products have been very, very well studied to make sure that they are as safe as science can tell us they are. But even though these products have been tested, we still want to make sure that we are wearing our proper protective equipment. And it may seem like overkill going out into the garden and throwing on a pair of jeans, a long sleeve shirt, rubber, some rubber muck boots, and a mask. But it is very important, especially to prevent some of that long-term chronic exposure. One of the things that really irritates me is when I see people applying pesticides wearing sandals and shorts. So much of that product is now going to wash onto, it's going to drift onto their clothes, or onto their bare legs, onto their bare shoes or bare feet, and that product can then be tracked elsewhere, or not wearing gloves. One of the things that the past 18 months of all the COVID stuff has shown people is how important it is to not be touching our faces when things are dirty, when our hands are dirty. And it's very, very easy when out applying pesticides just to you start itching your forehead, or wiping sweat out off of your brow. Even if you do have gloves on, you don't want to be you don't want to be rubbing your face with any of those pesticides as well. Now, some of the other adverse health effects can occur if we're not following those pre-harvest intervals. So again, we really need to be reading the label when applying these things, making sure that we are following the label recommendations, and we're not applying these pesticides too close to when we are going to harvest the fruit or the vegetable, because we want to make sure that any of these pesticides have either washed off or become inactive before we are going to consume them. And finally, the ugly effects of our commercial pesticide applications. Biggest thing to me, the biggest ugly ones are we can have phytotoxic effects, which nobody wants. Those are the off-target. That's when that's when the plant responds and we start to see injury occurring on the plant only due to the product that we had applied. From my standpoint, one of the most concerning things is pesticide resistance. And so if we are over applying some of these pesticides or not applying them properly, the pests we are trying to control, eventually they may develop resistance to whatever product we are applying. And we only have so many products that we can apply. Once the pests have developed resistance to any of those products, it's going to be much, much more difficult to control them. And really we'll have to purely be resulting or purely go back to our cultural methods of control. So phytotoxicity tends to be worse on our stressed plants. And so maybe they are damaged, maybe they're drought stressed, or we had a lot of winter injury or frost damage this past year with that extreme cold spell that we saw. That the frost and drought are a couple of big stressors that can end up leading to some phytotoxicity. One of the other things that we may see is if we're applying, if we have some drought stressed plants and we apply any pesticides, but even fertilizers. A lot of our pesticides and fertilizers are salt-based products. And if the roots are super dry and we apply one of these products or one of these chemicals, those roots are going to try to absorb as much as they can because there's going to be liquid there. But as they pull more up, then that's when you can start to see some burn occurring as well. We also want to make sure that we're not applying things under adverse weather conditions. And so those would be outside of the label recommendations. Copper is generally considered to be fairly safe, but if we apply it in cool, damp conditions, we often do tend to see some toxicity that can occur. Another thing that we often see phytotoxicity occurring is when we're mixing multiple chemicals together and they are incompatible. And those two chemicals, they mix and they end up burning the leaves instead of causing or giving us the control that we are hoping for. And finally, plant resistance or pest resistance. And so these resistance is already out there in the population. One thing I want to stress is that pesticides do not cause these mutations to occur. And so resistance problems always result from natural mutations. The pesticides do not cause those mutations to occur. What the pesticides do is they select for those resistant mutations. Almost every mutation that occurs has some sort of fitness cost. But the more we are applying these pesticides, we are now selecting for these resistant populations. And then when we come back later in the season or next year, the products that we applied are not going to be near as effective. Some of the weather conditions, we want to be paying attention to wind, making sure that there is a little bit of wind. If we have wind speeds less than 3 miles an hour, wind gets very erratic at that time. And so making sure that when the wind speeds are really between that 3 and 8 miles per hour, that's when the product tends to drop exactly where we want it to. Also want to be paying attention to temperature and humidity. And so high temperatures and low humidity tend to result in higher volatility of a lot of our products. Another thing we want to pay attention to are temperature inversions. Temperature inversions occur when the cool air further away from the Earth and the warm air closer to the Earth's surface kind of just flip. And any of those products, they can then travel much further. We can have much more substantial drift occurring during those temperature conversions. And then finally, we want to make sure that we are reading the pesticide labels. The label is the law. And so making sure that we are only applying to control pests that are on that label. Also, that we're only applying the pesticide on plants that are labeled. And then making sure that we are following those proper temperature requirements and dosage as well. In the label, that will give us a dosage, how much of this product needs to be applied. That dosage is important to prevent phytotoxicity, but it also helps prevent resistance from occurring later. And so we do have our resistant action committees that are out there with a lot of commercial products. You may see a group number there on the label. You want to make so when we're thinking about rotation, making sure that we are rotating different group numbers. When going to your general garden store, though, we may not have that nice group number that's there. So in that case, we want to make sure that we are really inspecting our products and looking to see what are the active ingredients that we're applying. That's important to make sure that we're applying the right active ingredient for the pest that we have, but also so that we can rotate these and not apply the same product time after time after time. We do have a few resources here looking at any of these resistance action committees.